Okay, now we are in the exercise section and I will finish this exercise, this problem in a minute. So you have to watch how I finish this, and after that I will give you the explanation how to solve the problem, and also this exercise will be following with the second exercise, and in the second exercise I will give you how to solve this problem, and I will give the explanation after that. So keep watching this video. Okay, we have to exercise here. The first exercise is the forces F1, F2, and F3 are all which act on point A of the bracket. So all of three different ways of forces here working in the A point. Then we have to determine the x and y scalar component of each of three forces. So firstly we have to make the exploded drawing. It will help you to make it easier. So you have to make three. It is the first forces, it is the second it is the second one, and it is the third one. After we have this one, we can solve. Firstly, we have to solve the F1 in the direction of x and F1 in the y direction. So we have to find the component of F1 in the x direction, and here also F1 in the y direction. For the F1 is in the x direction, we can use this formula. F1x is equal to 600 cos theta. The theta is 35 degree, so it will be F1x is 600 cos theta times 35 degree. We will have the 491. And also for the F1 in y direction, we have 600 sines 35 degree. We will have the 344 Newton. And for the second exploded drawing, you have here it is. We don't have any angle information here. There are no given information for the angle, but we know there is the equal of the trigonometry, so we can use this information. So if here is 4, here 3, so we will have 5 here, and here is minus 5 for F2 in the x direction, so we have to use this one. For F2x, it will be equal to minus 504 divided by 5, because it is the cosines of this F2 in the x direction. And then the second one is for F2y. It's mean that F2 in the y direction, we will have the 500 here times 3 divided by 5, which is revert to the sines, right? and then we will have the 300 Newton. And the last one, the third, we have this unique information. So each of three forces have a different information, and in the F3 we don't have any information such as the angle and also the trigonometry information. So we can use the one of our formula I have given in previous video, that we can use that alpha, it will be equal to tangent to the power of -1 fy per divided by fx, but I'm using here fx divided by fy. You can also use fy divided by fx, but after that you have to choose 90° minus the result of this one directly. If you don't want to wasting your time to reduce this, you can reciprocate this one, so fx divided by fy. So we will have the 0.2 divided by 0.5, 20.6 degree I mean. And then after that we have this angle. We obtained this angle, and then we can continue to find the F3 force 3 in the x direction and also in the y direction. We can use the same equation with the first equation, this one, to the same 800 sines 26.6 degree will be 358 Newton, and then F3 in y direction it will be minus 800 cosines 26.600 will be minus 716 Newton. And the second exercise. In this exercise, we have to combine two forces in a P and T which act on the fixed structure at B. So we have two forces here, is the first one and is the second one, and here where the forces was acting, and two of them, both of the force P and T working on a point B. So firstly we have to looking for the number of alpha. Alpha is here. So what information we have? We only have information of this B to C. It is 6 feet mean here, and then we have this angle 60 degree between the B, C, and D. So by using this, we can use the previous previous equation. It is the B and D is Y, and here is x. Yeah, in x direction, in a y direction, and here divided by the x direction. We have 6 sines 60 degree. Yeah, here 6 sines. So we project this one to this, and then we have projected the BC here, this first here, to this. So we will have 3 plus 6 cosines 60 degree, and it will be 0,866. So it's still in the tangent theta and the tangent alpha, sorry, I mean it's alpha, and the alpha it will be 40,9 degree. Please you have to remember that this problem can solve by using the parallelogram law or triangle law. So please give the exploded diagram for 1 or 2 of the method. Firstly, if you want to know the resultant, because we have to combine, so it means we have to find the resultant of these forces. They're working on B, and it is the force of T. The first is the first force, it's the second one, and we just get this number. So what we are doing, we are using the cosines law. By using the r square, it will be 600 square times 800 square minus 2 times 600 times 800 cosines of 40,9 degree. It will be 524 pounds. If you want to know in what direction, we have to know the angle of the R from P. So we have to the angle here. And the easiest way, we can transform this one into the triangle law, and we use the sines law. From the sines law, here in the front of, here we have we are looking for this. So 600 divided by sines theta, then we have known this, it will be 525 sines 40,9, yeah, 40,9 degree is from the previous calculation. For this one, you will get the sines theta, it will be 0,75, and the theta it will be 48,6 degree. I think that's all for the exercise, and maybe in this end of the video I will give you the exercise. You can try to solve the exercise, and you can send your answer to my Gmail, and I will give the reply of your Gmail, and I will give you the correction of your answer sheet. Thank you, that's all. Assalamualaikum.